Okay, hello everyone. Let's go ahead and take a look at something slightly different. Now before we were always trying to determine whether or not an infinite series is going to converge or diverge. Well, in this particular section here, what we're trying to look at is, given an alternating series, can you actually approximate what the actual sum will be, assuming that it converges? So remember before we said that it's not important for us to know if a particular series converges to a particular value. We only needed to know whether it converged or diverged. Given an alternating series that does converge though, we can then go ahead and approximate what that sum actually will be without having to add, of course, the infinite number of terms that you have, which would of course be impossible. Let's go ahead and take a look, for example, the alternating series estimation. And again, this is going to be for converging alternating series only. Now, if a converging alternating series satisfies the condition a sub n plus 1 is going to be less than or equal to a sub n, okay, remember that this is actually going to be the same thing as saying that it is monotonic decreasing, then the absolute value of the remainder, and let's go ahead and call that r sub capital N, involved in approximating the sum s by s sub capital N is less than or equal to the first neglected term. Now, if we wanted to go ahead and just take a look at that and put that into an initial statement, this is what it would look like. It says that your remainder of the difference between the actual sum and the sum up to the first n terms, so in other words, we're talking about an nth partial series, is going to be less than or equal to the next term in the alternating series. Okay, so let's go ahead and take a look at an example so that we can put some concreteness to this. For example, let's go ahead and say that we want to approximate that infinite series there, which is negative 1 raised to the n plus 1 divided by n factorial by its first 6 terms. Now, if we go ahead and just write that out, this is what it's going to look like. We have 1 divided by 1 factorial minus 1 divided by 2 factorial plus 1 divided by 3 factorial, and on forever. So the main thing that we need to do before we can actually go ahead and use this is we need to make sure that the series converges, and we also need to make sure that it's monotonic decreasing, as well as that the limit as n approaches infinity of the series sequence itself goes to 0. Now, if we go ahead and take a look at the nth plus 1 term, is that always going to be less than the a sub nth term. And in this case, of course, if we just go ahead and take a look at 1 over n plus 1 factorial and compare that to 1 over n, then sure enough, we know that 1 over n factorial is always going to be less than or equal to 1 over n for all n being a positive integer. So the first condition that we need is fine. It's monotonic decreasing. We need to also go ahead and make sure that the limit as n approaches infinity of 1 over n factorial is 0. And sure enough, that is also true. These two conditions put together ensure that we have a converging alternating series. So therefore, we know that this converges. Now, what we can do then is we can go ahead and apply this particular initial statement to determine an approximation to what this alternating series is actually going to be equal to, being that it is converging to a value. And we'll go ahead and, again, approximate it to its first 6 terms. So what that means then, well, I went ahead and just found out what the sum of this here is going to be up to that term. And it's going to be approximately 0.63194. Now, I need to go ahead and also find out what a sub 7 is. A sub 7 is just going to be 1 over 5040, which is about 0.0002. Now, if I wanted to go ahead and approximate again what the sum is, I just have to go ahead and use this inequality here, because the sum is what we're looking for, minus s sub 6, which is approximately that. It's got to be less than a sub 7, which is going to be that. And again, all I have to do now is solve for the inequality. And I know that the sum is going to be someplace within this range of values. So again, notice what's happening is that we're not actually finding the sum, but we're approximating it. And that's the whole idea of approximating an alternating series that is convergent. Okay, so again, make sure that when we go ahead and have a converging alternating series, we need to just make sure that it's monotonic decreasing, as well as the limit as n approaches infinity of the sequence is going to 0. If we know that both of those are true, then we can use this initial statement here to approximate the sum to whatever degree we want. Okay, so we'll take a look at a couple of examples of that in class the next time that we meet. See you later.